Okay, next for question number 2, we have a question here to find all the equations of line 1, 2, 3, 4, and 5. So we get one by one. So you can see from line 1 here, this is line 1. We have a straight line, so all the lines are straight lines, so it is going to follow the equation y equals mx plus c. So line 1 will have the form y equals to mx plus c, and again, as we have done before, we are going to find the value of m and the value of c from this diagram. You can see that c is the y-intercept. So if you look at line 1, it cuts the y-axis. This is the y-axis. It cuts the y-axis at 0, so the y-intercept is 0. So this equation here can be simplified into y equals to mx plus 0 as the y-intercept. So this is the 0. The line is cutting at 0. So it becomes y equals to mx. So our final task is to find the value of m. And in the previous section of our chapter here, we have learned that m can be found by using the formula y2 minus y1 over x2 minus x1. So m is equals to y2 minus y1 over x2 minus x1. So we need to find our y1, x1, y1 and x2, y2 points. So if we look at the line, we can actually select 2 points here. I can see one of these point here is at 0.11 and another point probably here at 2 here. So if you were to label this as x1 y1, x1 y1 here, and x2 y2 for the 0.22, I can just substitute y2 minus y1, so that's 2 minus 1 over x2 minus x1, so that's again 2 minus 1. So I can find the gradient of the line. So by using these 2 points, y2 is equals to 2, so that's 2 minus a y1, so y1 is equals to 1 over x2 equals to 2 and x1 equals to 1, so 2 minus 1, and this will have a value of 1 over 1, which is equals to 1. So the value of m is equals to 1. So that means my line 1 therefore my line 1 is going to have a value of y equals to 1x, and y equals to 1x. 1 times x is just x, so this is the final answer for line 1. Okay, for line 2, so line 2, we have another line going here, and again it will follow the equation y equals to mx plus c. So line 2 will be having this form y equals to mx plus c. So our task here is to find m and to find c. So if you look at the line 2 here, we actually have the c given here. So c is the y-intercept, so you can see that the line 2 is cutting at 3, so c is equals to 3. So y equals to mx plus 3. So final task is to find m, and we are going to use the same method that we have used before, which is to use the formula y2 minus y1 over x2 minus x1 for the value of m. So m will be equal to this formula that we have, but we're not going to write it again, so we are going to find 2 points in L2. So I can choose one of the points here. This is the coordinate 0, 3, and we have another point here, and that is 2, 4. So from here we have x1 y1 and x2 y2 label. So I can find the gradient by using y2 minus y1, so that's 4 minus 3 over x2 minus x1, so 2 minus 0. So 4 minus 3 over 2 minus 0. So 4 minus 3 have a value of 1, 2 minus 0 is 2, so the gradient here is half, m equals to half. So I'm going to replace m by half, y equals to half x plus 3, and that will be the answer. So L2, the final answer will be y equals to m will be replaced by half, so that will be half x, and I'm going to follow with plus 3 here, plus 3. Okay, next we have the line tree. So line tree, if we look at it, is here. This is line 3. It's a straight line, so again it will follow y equals to mx plus c. So line 3 will be y equals to mx plus c, and we are going to find the value of m and the value of c. So let's take a look at the diagram, see whether we can find any value of c. If we look at the line, the y-intercept is -2. Okay, so this line is cutting the y-axis at -2. So my c here will be -2, and this will be updated to y equals to mx plus the -2, so it will be -2. So final task is to find m. So I will use a formula for gradient m, and I'm going to choose 2 points from here. So one of the point that I can use is here. This is -2, 1, and another point on this line L3, good point will be here, and this point here is 0, -2. So before we use the gradient formula, we're going to label this. So I'm going to label this as x1 y1. So x1 will be 0, y1 will be -2, and the other point -2, 1 will be x2 y2. So I'm going to straight away use the formula y2 minus y1, so that's 1 minus a -2 over x2 minus x1, so -2 minus 0. So 1 minus -2 and -2 minus 0, and that will give me a value of 3 over -2 as my gradient. So for the final answer L3, I'm going to have y equals to m, so m is -3 over 2 x minus 2. So that's the answer for the line 3. Okay, for line 4, you can see that line 4 is a horizontal line, and we actually have an equation for that, and line 5 is a vertical line. So you don't have to use this formula, the method that we have. You can just refer to page number 2, okay, page number 2 of this section. You can see that y equals to c is a horizontal line cutting at c, and x equals to a, this vertical line x equals to a is a horizontal is a vertical line cutting at a. So if we look at this will be y equals to whatever that it cuts on the y-axis, and here will be x equals to the value of a which cuts on the x-axis. So by following these two formulas, we can easily find L3, okay, because L3 here, L4, and L4 here is a horizontal line cutting the y exists at negative 2. So y equals to negative 2 for L4. So the value for this, or the equation of this line, will be y equals to negative 2. And the final one, which is line 5, you can see line 5 is a vertical line cutting at x equals to 5. So this equation of the line is x equals to 5. Okay, so those are the answers for question number 2. So the first answer, line 1, will be y equals to x. Line 2 will be y equals to half x plus 3. Line 3 is y equals to negative 3 over 2x minus 2. And line 4 is y equals to negative 2. And line 5, x equals to 5.